When we're trying to solve exponential equations, we want to try to make the bases the same. So if the bases are the same, then if we have an exponent on each side of the equal sign, that means that the exponents are going to be equal to each other. So if we look at the first example, 2 to the x equals 32, we want to try to make the bases the same. So we have 2 to the x, and we can rewrite 32 as 2 to the 5th. So now that the bases are the same, they're both 2's, we just have the exponent equals the exponent. So x equals 5. Okay, on number 2, we have 3 to the 2x, and then we're going to rewrite 27 as 3 cubed. And then we have that x plus 1 that's still in the exponent. So now that both bases are 3's, we have 2x equals, and we're going to distribute the 3 to the x and the 1. So 3x plus 3. And then we're just going to solve this for x. So we get, if I move the 3x over, negative x equals 3. So x equals negative 3. With the third one, you have 8 as a base and 16. They both can have 2 as their base. So instead of 8, we can rewrite that as 2 cubed to the 2x. And instead of 16, we can write that as 2 to the 4th to the 4x minus 5. So now that the bases are the same, we just put the exponents equal to each other. So 6x equals, we're going to distribute the 4, so 16x minus 20. So if we subtract the 16x, we get negative 10x equals negative 20. So divide by negative 10, x equals 2. And on number 4, we're going to make both bases be 5. So 5 is already here. X squared plus 8. And instead of 125, that's 5 cubed to the 2x. The bases are the same. So x squared plus 8 equals 6x. We're going to bring everything to one side. So x squared minus 6x plus 8 equals 0. So now we have a quadratic, and we're just going to factor this. So multiply this to 8 adds to negative 6. We have x minus 4 and x minus 2 equals 0. And we get x equals 4, x equals 2. So if we look at a couple more examples, so the first one, the bases are the same. So we're just going to say 7 minus x equals 2x plus 1. And we're going to bring the x together, and we're going to move that 1 over. So now we have 6 equals 3x, so x equals 2. Nine, we can change 9 to be 3 squared. And then we already have a 3 on the other side. So now that both bases are 3's, so we're going to have 2x squared equals 3x plus 2. So now we're going to bring everything to one side. So 2x squared minus 3x minus 2 equals 0. And we're going to factor this. So we need a times c here, since my a value is not 1. So multiplies to negative 4, adds to negative 3. So we're going to use negative 4 and 1. We're going to bring down the 2x squared. We're going to bring down the negative 2. And we're going to rewrite negative 3x using negative 4x and positive 1x. And then we're going to group it. Take out the GCF, which is 2x. We're left with x minus 2. Take out the GCF of 1, and we're left with x minus 2. So we have 2x plus 1 and x minus 2 equals 0. So we're going to end up with x equals negative 1/2 and x equals 2. And now in number 7, we have 1/2. Well, because we have a fraction, we know that the exponent has to be negative. So I'm going to rewrite 1/2 as 2 to the negative 1 power. And then that's 6 minus x. And then 2 is just 2 to the first power. So now that the bases are the same, we have negative 6 plus x equals 1. So x equals 7. And in the last one, 27 and 9 become 3 as a base. So 27 will be 3 cubed, and then we have x minus 1. 9 is 3 squared, and we have 2x plus 3. So since the bases now are both 3's, we're going to have 3x minus 3 equals 4x plus 6. And we're going to bring our x's together and our other terms together. So we end up with x equals -9.